Hi, I am Samson Griffin, and I am here to show you the logical component of Team 122's ARR. So once you click Run, which I just did, you will then click your starting home location, and I'll choose Zone A. And as you can see on the warehouse, after you input a random barcode, it will then travel through the warehouse, going through Zone A, then Zone B, then Zone C, then Zone D, while outputting all of the barcodes, proving that our ARR is reading all of the barcodes. And if you look carefully, you'll be able to notice that our ARR only reads the barcodes from the zone that it is meant to be reading from. So soon it will go in between zones B and D, but after B, which it just went through, it is going to move to C, so no barcodes will be outputted here, and only two upper boxes will be outputted in the command window because it did not read these two lower boxes, which it had previously read after it passed by them, finishing with Zone A, moving to Zone B. But since it's moving from B to C, it will only read the box barcodes from Zone C. And as you can see here, it will not output any of these barcodes as it is unnecessary. And now it will only read the upper boxes which come from Zone D. And after it moves through the remaining section, which is Zone D, it will then go around the outside to, in a efficient way, return back to its starting point, which is Zone A. And since the program is finished, we can now show the IPS system, our internal positioning system, and we can copy that function, paste it really anywhere we want. Just to make the video shorter, I will try and place it close to where it starts, and we'll paste the IPS system. And now if we run the program, we'll be prompted with the same messages. I will choose the same home, enter a random barcode, which is impertinent to our IPS performance right now. So as it runs through, when it gets to the point where the IPS program was placed, you will receive a message that says, "Oh no, the robot is lost. Select IPS," which is here, to receive radial distances and compute the locations. So once you click that in the command window, from that point you will be shown the radial distance from Tower A, which is 45.61, the radial distance from Tower C, which is 116.62, and the radial distance from Tower D, which is 119.87. And then if you want the X and Y coordinates of your ARR, then it will be outputted as the X position being 50 and the Y position being 6. So then after you click continue, the box will continue to run through the rest of the virtual demonstration while still proving that it can output barcodes all at the same time. So we are going to pause our function, our code, to speed the video up slightly. We're going to quit this debugging, get rid of the IPS function, which I seem to have lost, which is right here, which is kind of hard to lose since it's so big, but never mind that. Then we will go to the box transport function, copy that, paste it in a place that is close to the start because we don't have that much time, but it can be placed in any position. Maybe here. And as it is placed in this position, you will see that when you run the program, you'll be prompted with the same two pop-ups. Choose Home A, enter a barcode, which you want the box, a barcode of a box that you want to be transported. So I'm going to choose a random barcode. Hopefully it's close to the start. And then I'll enter to input that into the box, and you can see slightly that the box was picked up and then virtually returned to Home A. And since this is finished, we can pause the function, and then since that is paused, we will wait for it to finish debugging, take that function out, and then input the collision avoidance function through the same process of copying and pasting into the official code. And we should probably put it somewhere close to the beginning, maybe in the same spot. Doesn't matter where you put it though. And now we will run this program. You are prompted with the same things, and I will choose the home location as A also. Input a random barcode, since this does not matter, to show the collision avoidance system. Enter, and you can see now there is a red marker. And since the box stops in front of that marker and virtually avoids it, proving the collision avoidance system. Thank you.